Hello everyone, I am Paramita and today I am going to discuss about manual testing. Now in this video I am going to discuss about uh, manual testing in brief. Like I will try to touch each and every topic, but in future I am going to make a video on each topic separately to give more elaborate view. Why I am doing this video? So that we can discuss like after this video I'm going to make a video on like a live project of manual testing. There we will discuss like in reality like how we are going to do the testing, like how we will prepare the test documents, requirement analysis, test planning, and then we'll write some test cases and how we design the test and everything. So for that, whatever we need to know about manual testing we'll discuss here in brief. So this is good for people who has already got some knowledge and but they want to revise their knowledge so that they can do further discussion for that live project. Or it's good for people also who is just starting, because it will give an overall view about the subject. And after that, if you need more elaboration, you can see my next videos. I will make videos for each and every topic. Okay, so we'll go to the next video, sorry, next slide. So now first thing we need to know that what is testing, what is software testing actually. Okay, software testing is a way to assess the quality of software and to reduce the number of defects in it, and thus to reduce the risk of its failure in operation. Okay, so basically the software testing is a way to assess the quality of software. How is the quality of software? Like it's a high quality or low quality, So by software testing we see the quality of the software. So I said that to find out the defect in software we do the testing. So what is the defect? So defect is an error, mistake or flaw or fault in a software which may cause failure. Like for example, we are human being, so we can make mistakes. Okay, so defects can be from human mistake or from machine error. There can be a lot of different types of defects, but here I gave you some example. Like client wanted to have a drop down menu at a front end of a web page, but the business analyst who gathered the requirement from the client omitted business that in the business requirement documents. Okay, so she omitted that she or he omitted that requirement for the drop down menu. Now when the developer is going to develop the software, so maybe he will just make some radio buttons or check buttons. He will not do the drop down menu, but the client wanted that menu. So the client had his own purpose. So in that case, when it will go for the acceptance, the client will not accept it, or he will not be satisfied, because he will say that I wanted the drop down menu, you have to do the drop down menu. So this is a defect in the software. Then the developer forgot to declare some variables. Like in some languages, there are like in each programming language, Java, PHP, or Python, there are some rules. Like there are some specific rules in each language. In some language they require all the variables to be declared. Like in Java, they require the variables to be declared. Suppose the developer used the variables, he did the coding and all, but he forgot to declare the variable in some part of coding, then there will be fault. So that is another structural fault. So there can be different types of defects. The defects can be in the documents, the defects can be in the programming coding, so like this. Okay, so but eventually because of that defect your software will be affected. Maybe the software will not serve the purpose of the customer, or the software will not work at all. If the defect is a big defect in your coding and all, the software will not function at all. So defects can be different types, and on the basis of that, impact will be different. So this is another topic, like a defect can be more severe, less severe. So in that case, we have to decide the priority of the defect different based on the risk and impact. So that's a different topic we will discuss in some other video. Okay, so I just gave a brief idea of what is defect. Now, the principles of testing. There are mainly 7 principles of testing. What are they? I'll just give you the brief idea of those principles here. Testing shows presence of defects. Yes. So testing, we do software testing to find the defects. Okay. But nobody can give you a guarantee that in any software or application there is no defect. So testing doesn't talk about that there are no defects or all defects are fixed, all those stuff. That's not testing purpose. Testing shows the presence of defect. The purpose of testing is to find out the defects. Okay, so that's our job, but we cannot say anytime that there are no defects in your software, all defects have been fixed. Testing cannot guarantee that. Okay, then exhaustive testing is impossible. Yes, exhaustive testing is impossible. Like even if we do a lot of testing, but still the same thing, that complete testing, it's impossible. Like that your software is defect free, it's impossible. Maybe you do a lot of tests and all, still there will be something left that can come up in future. You will find that there are some defect. Okay, so exhaustive testing is impossible. Early testing saves time and money. Yes. Now there are different stages of testing. If that I will discuss later on. So if it happens like you started developing a software, and suppose in requirement, that's one of the first phase of the software development. When the requirement is gathered, like the customer told that he wanted something, like in my last example I told that a customer wanted a drop down menu, but um, but it was omitted. Someone by mistake they omitted that requirement. Instead of drop down menu he put checkbox or radio button. And if we don't find out that defect in the beginning, suppose the developer developed the whole software, whole coding he did and everything is done, and at the end we find out that there was some mistake. So then what happens, this is the case of drop down menu, but it can be some other major thing also. If they want to change that, maybe they have to change the whole software again, or they have to do a lot of work, they have to change different in they have to make changes in different modules and stuff. So it will be a lot of job, so waste of effort and waste of money also, because more hours we have to work on that. For that we have cost. So if you're testing, like, so that's why early testing saves time and money. If you can start testing at early stage only, so then you can find the defect soon, and it will take less time and less effort, and so less money to fix the defect. Okay, so that's why this is a very very important principle, that early testing saves time and money. Defects cluster together. It's often found that in particular in particular portion of a software, lot of defect exists. The experienced tester, who are experienced in testing, they can understand that in this portion of the software there will be a lot of defects. Okay, so they decide that from their experience and all, but we have to be careful about that, because sometimes uh, your your thinking or idea cannot be true also. If you use the same software again, like same testing again and again, sometimes it will not work properly because each situation can be different. Then beware of the pesticide paradox. This is an extension of the same principle which I discussed just before. Beware of the pesticide paradox. Like for farming, if you use the same pesticide for each type of crop, maybe it will not work. Whatever is working for the vegetables, maybe that will not work to get the good flowers. You have to use some different pesticide for flowers. Okay, that's why when you go to the Bunnings um, to buy the pesticides and not pesticides. Oh, sorry, I'm talking about the compost and all the stuff. No, sorry, pesticide means like that we use, like farmers use to kill the insects in the farm. So for different types of vegetables, different types of trees, maybe they need different types of pesticide. They cannot use the same pesticide for all vegetables or for all trees. Okay, so similarly in testing also, for different projects, if you continue to use the same test cases, suppose same test cases using your automation tool for regression testing and all, again and again for all the projects, maybe you will not get the same result because each project has its own specialty. So beware of that repetition, that when you do repetitions, good idea is to check the project and depending on the situation to make improvements and changes. Okay, so that is actually stated by this principle, that beware of the pesticide paradox. Then testing is context dependent. Of course, testing is context dependent. You have to see that in which context you are doing the test. According to that, you have to design the test cases. Like in banking software, you will do some different types of test cases, and in a medical software, you will do some different types of test cases. So, of course, testing is always context dependent. Absence of errors is a fallacy. I told it before also, like testing doesn't guarantee that the software is going to be defect free. Testing finds the defects. So maybe you did a lot of tests and all, but still you can't say that our software is defect free or error free. Okay, so testing can't guarantee that one. So absence of errors is a fallacy. Then software development lifecycle. Now software testing is carried out in different way depending on the software development, which software development life cycle we are using. Now what is software development life cycle? The software development life cycle is a process of planning, creating, testing and deploying of a software or application under development. Okay, so during the development, basically the software goes through different stages. Like we have to plan how we are going to do the development, then we have to test also, like we have to develop the software and then we have to do testing and then we will deploy the software. So these are the different stages of developing a software, and this is called software development lifecycle. Now there are different types of software development lifecycle. like for example waterfall model, V model, iterative model, agile. And so these are some different types of software development life cycles. Some we will discuss here, and then we will discuss the software testing life cycle on the basis of software development life cycle. Now, waterfall model of software development life cycle, how is that? You can see in the diagram, waterfall method is actually quite traditional and sequential software development life cycle. In waterfall model, what happens? All the stages are done like sequentially. Okay, you cannot change them. Like in the beginning, there will be requirement gathering. See, requirements. We have to take the requirements from the clients, and these requirements will be fixed. Once you are taking the requirements, once it's accepted by clients, it cannot be changed. It's fixed. And after finalizing all the requirements, those requirements will be analyzed, and depending on that, they will design like the whole development structure, how they will develop the software and all. They will design, then they will do coding, that means they will develop the software, and then there will be testing after development. So the testing will be done at the end. Before development there will not be any testing, and after testing there will be like they will present the software to the client, and the client will accept it. And what's the there are a lot of advantages of waterfall model, like it's very systematic, and the quality of software will be very good because it's systematic, everything is, all systems are followed. But there are a lot of disadvantages of waterfall method, like no flexibility. As I told, that requirements are finalized at the beginning only, and after that it cannot be changed. Like suppose sometimes it takes long time to develop a big softwares like Facebook, WhatsApp, it takes long time. So by the time its development is finished, maybe the requirement of the customer will change, because this industry, IT industry is very fast. So what happens, like within 1 year and all, there will be a lot of changes. So maybe the customer's requirement will be changed that time. So by the time the software is developed, maybe it will become obsolete. You have to do remodeling or something like that. So that's a very big disadvantage for waterfall method development life cycle. What happens here? It takes long time, and by the time it's developed, maybe customer will change his mind. It will not fulfill the customer's need. Not only that, what happens, because testing is done at the end after finishing the development. So if there was some mistake in requirement, because it was not tested, requirements were not tested, it was not reviewed. So if there was some small mistake or something, or if even there was some mistake in analysis or designing the software, so at the end when we find the defect, it's already late. To fix that, we have to change again from the beginning. It's a big job, and wasting of time, wasting of effort, wasting of money. So that's why early testing is not possible in waterfall model. So that's a very big disadvantage. Then have to wait long time for getting the software, risk of more surprise. I already discussed that one. So by the time you get your software, maybe your requirement will be changed, and the requirement are fixed, client is fully decided. So these are the very big disadvantage of waterfall method, that less flexible, and testing is done at the end. So it takes long time to finish the job, and at the end there will be risk of big surprise if the customer will be satisfied at all, because during our development and all, we are not going to ask him, do you want to see how it's going on and all. So there will be less flexibility, less interaction with customers, so eventually all those things will have a more risk of customer dissatisfaction. But in some places, in some situations, still waterfall model is followed, like where the customer is really decided about the requirements and all, about the budget. If he's really decided, he is not going to change at all. So in those situations, we can use waterfall model because it's a systematic model. The quality of development is really good. Okay, so still in some situations, waterfall model can be used. Then after waterfall model, because of those disadvantages, to overcome those, we came up with V model of software development lifecycle. You can see the diagram, its structure is like V. Okay, and there you can see in V model still there are some stages, the same stages like requirement analysis, system design, then architecture design, module design, coding. So same stages are there, but here the big advantage is this: in each stages, along with development, they do the testing also. Okay, so for each stages they are doing the testing, so early testing is possible, so it's more flexible than waterfall. So more flexibility compared to waterfall. Then, though there are also sequential phases, but testing activities are carried out from the beginning at each level of testing. Like requirement analysis, when they do the they gathered requirements and then do requirement analysis. At the same time, they make the test cases for acceptance testing, like based on the requirements. Okay, then system design, when they are doing the system design, at the same time they do the system test design, they write the test cases and everything depending on this system designs. Then architecture design, when they are designing the architecture, the structural design, that at the same time they are doing the integration test design, integration test cases, all those stuff. When they are doing the module design or unit design, at the same time they will do the module test design or unit test design, and they will do the unit testing, and then coding and testing. So basically you can see here there are different phases of software development, but in each phases they are doing software testing as well. So there are more flexibility, like in the beginning only in requirement, if there is some mistakes, some errors, they can verify that with the customers, and they can take feedback from customers also that how the requirements are going on. So it's more flexible, early testing is possible compared to waterfall model. And yeah, so that really makes a difference. So V model is far more flexible, and it takes more feedback from customers and all, so it will reduce the risk of surprise. Okay, now after V model there came iterative development model. There are actually different iterative development model like agile and all, but that I will discuss later on in separate videos. Now, what is iterative development model? So an iterative development model, the process of developing a large application. Okay, so what's happening in iterative model? The large application, like which we are going to develop, a large application, software, whatever, that is divided in small parts. Okay, and here also we do the same phase of development. We have to do the planning, we have to analyze requirements, we have to analyze the design, and we have to then implement, and we have to testing, and then we'll deploy. So the same phases will be followed here also, but what's the difference? The difference is that the software which we have to develop, it will be divided in small parts, and we will do the same phases for each part. Like maybe suppose the Facebook or WhatsApp, they have different features. They have like login function, then they have messaging function, they have uploading photos function, then sharing function. So lots of functions. They didn't develop it in one day. So what they did, maybe the at first phase, they did the login function, and they did everything like planning, requirement, design, development, testing, everything they did for that one, and then they deploy it in the market. So the customer who ordered the software, he will also be satisfied that yes, I got something, and that is totally tested. That part is totally tested, and we got the customer's feedback also during the development. If he wanted some changes, small changes, that's quite possible. We don't have to change the whole program and all. We can do this very easily, and finally it's deployed to customer's environment, and customer is happy. And then we go to the next part of the software, maybe messaging. Then we do the messaging, and then the messaging came, and the customer got already the messaging, and not only that, he will be able to use the those parts of the software. He will already start so in the current market. And then again we will develop some photo uploading function and all. Then again we'll do. So basically we'll follow all the stages, but in each part, small parts. So that's why and each part is called one iteration. So that's why it's called iterative development model. Okay. So here what happens, the customers are involved from the beginning. We get customers feedback. So it's really flexible. In the beginning only, customer doesn't need to decide all of his requirements. By the time we do one part, customer can change some requirements for the next part. So that's how we can understand customers' behavior. Customers need more. So it helps a lot to reduce the risk of dissatisfying customer. Customer will be satisfied, and we get early feedback. So it saves our time, money, effort for fixing big defects at the end. Okay. So this is a really flexible model, and nowadays most of the organization use different types of iterative development models, actually, like agile and all. So we'll discuss those models in some other videos, but this is like what is iterative development. Now, software testing life cycle. So depending on the software development life cycle, we will see different types of software testing life cycle as well. So software testing life cycle is basically a series of specific activities conducted methodologically during the process of software testing to achieve the goal of software testing. It involves both verification and validation activities. Now, what is verification and validation activities? I'll discuss that in a separate video. Okay, that's a very good concept we need to know for software testing: verification and validation. The major phases in each software testing life cycle are as follows: requirement analysis, then test planning, test case development, test environment setup, test execution, and test closure activities. Now, requirement analysis already I discussed, like we have to gather the requirements from the clients, what they require actually. Then on the basis of that, we will do that planning for the test, like the scope of the test, everything will be there in test planning, like how we are going to do the test, what types of test we are going to use, what types of test techniques we are going to use. So all those stuff will be in the test planning, and then test will analyze the test basis and all, and then we will do some test case development, test environment setup. Before doing testing, before running any testing, we have to set up the environment, like the softwares we need, or the platform, and everything we have to do. We have to set up those, and then we have to execute the test. Okay. and then at the end test closure activities. So all these topics I will discuss in detail in several videos later on, one by one. Types of testing. Now, depending of different uh, different like from different perspective, like depending on objectives or depending on change, like on various basis, we can talk about different types of testing. Now, mainly there are two types of testing, like dynamic testing and static testing. Dynamic testing executes the software under test, okay, and in static testing code is not executed. Okay, so that means what? Like, so what happens? Suppose we have to check, like we have developed one login function, user login function in a software. So to check that one, to check the functionality of that login module, what we will do, we will put some valid username and valid password um, in the input field, and we will just check it if it's working as intended or not. Like as per requirement, probably if we put a valid username, valid password, we should be logged in and land into a home page or product page or whatever. And at the same time, if we put an invalid username or password, we should not be allowed to log into the page. So this is the functionality. So if we want to check that one, we have to do that. So we will first so this way, when we check any functionality of software, like whether it's working or not, so these types of tests are called dynamic tests. Here we have to run the software, but static test, we don't run the software. Like some example of statistics will be like reviews, technical reviews, walkthroughs, inspection. Like when we do testing in the beginning, when we make the requirement analysis documents, plan, test planning, and all, we review those documents. That's an example of static testing. Okay. So in static testing, we don't execute the code. Now, dynamic testing validates the output with the expected outcome. The main objective of the static testing is to improve the quality of software under test by early detection of errors at early stages. Dynamic testing checks the functional behavior of software under test, like memory, CPU usage, and overall performance of the software product under test. The main objective of this dynamic software testing is to ensure that the software product under test is working as intended as per business requirements. Okay, so yeah, this is all brief discussion about dynamic testing and static testing. Now, depending on objectives of test at different level of testing, there are four types of testing: functional testing, non-functional testing, structural testing, change-related testing. Functional testing refers to the testing of the functionality of the software under test on the basis of requirements specified and business process. Functional testing is carried on throughout the SDLC at all stages of testing. The techniques used for functional testing are often specification based. For example, equivalence partitioning, boundary value analysis, state transition testing, decision table testing, use case testing, pairwise testing. Experience-based testing techniques are also used for functional testing. For example, exploratory testing, error guessing, checklist-based testing, defect-based testing. Now, if you want to know more about all these testing techniques like equivalence partitioning, boundary value analysis, etc., I'm going to make another video on the topic of testing technique. There you will be able to see about all this black box testing, white box testing and everything in detail. Now, non-functional testing. Non-functional testing refers to the testing of behavioral attributes or quality of the system or component or integration of the software under test. Non-functional testing is also carried on throughout the STLC at all stages of testing. So functional, non-functional, both testing are carried out throughout the all level of software testing. Non-functional testing includes the following: performance testing, load testing, stress testing, scalability testing, efficiency testing, usability testing, maintainability testing, reliability testing, portability testing, interoperability testing, etc. Structural testing. Structural testing refers to the testing of structure of the system or component of the software under test. Structural testing can be applied at any level of testing, but mostly it's applied at component level and integration testing. But it can be applied at all level of testing depending on the situation. The techniques used for structural testing are known as structure-based techniques or white box techniques. Some of the white box techniques are statement testing, decision testing, path testing. Testing related to changes are mainly two types: confirmation or retesting. Confirmation or retesting is carried out after fixing a defect to check that the defect found is fixed now. Suppose when we are doing the integration testing, we found that there is a problem in the code. So what the tester will do, tester will find out the defect and he will communicate it to the test lead or to the developer. So developer will be notified about the defect and then he will fix it. He'll make a new code, he'll fix the defect found and it will come to the tester. So the tester, what the tester will do again the test, and again he will see if the previous defect has been fixed or not. So this is called confirmation test or retesting to see if the defect is fixed. Now regression test. Regression testing is carried out to check the side effects, if any, after any change in the software under test. For example, each time any defect is fixed, after that regression testing must be carried out to see if the new changes introduced any adverse effect in any part of the software under test. So remember, regression testing is not the confirmation testing. There is a difference. It's a very important question in testing. What is the difference between confirmation testing and regression testing? So regression testing is done after every change. It can be a fixing a defect or it can be a different change. Like we may need to change the software because of the change of mind of the client or some any other reason. If the software design is changed or something, maybe we need to make some changes. It's not because there was any defect, just for some other reason. Maybe we need to make some changes in the software. So for any changes, we have to do regression testing to see that because of this change, if in any other part of the software there is any side effect or not. So for that we do regression testing for any changes. Okay. Now I will finish this video here, but some topics are not covered here, like different level of testing, the documentation for testing, those I will discuss in a separate video. Okay, and then we will discuss a real project of manual testing, and there we will see how to write the test cases, test plan, and requirement analysis, all those stuff. And then we'll learn some automation tools also, like Cucumber, Selenium, Maven, and we'll talk about that after finishing this manual test. Okay, hope you liked my video, and if you like it, please subscribe and like my channel. Thank you very much.